All right, one more video for this unit today. We'll wrap this unit up. Let's just go down through the chart. If you're a chart person, I don't want to disappoint you. Now, you might notice if you're a chart person, I didn't talk about sublimation or deposition. And I actually was going to do that in the video of the phase diagram, but I just forgot. I got too excited, I guess. Sublimation, you probably have heard of sublimation. Dry ice sublimes. Okay, we're talking about phase changes, right? We're talking about phase changes in this unit. Heat of fusions, heat of vaporizations, and when you have a phase change that goes from solid to gas directly, so here is my dry ice. Now, why is it called dry ice? I made a funny, I don't know if you've seen the lab video yet, but I was taking my ice and literally drying it, and I called that dry ice. And I said, that's funny, right? And none of you laughed. Okay. Well, dry ice is another way of saying solid carbon dioxide. Now that's cold. That's like cold. But what carbon dioxide does, and this goes back to the, and here's why. You know the answer to this, yes you do. The last unit was on, begins with an I. Intermolecular forces, very good, Billy. Now you know that CO2 is actually a non-polar. I could draw the structure out for it, but trust me on this, it's not polar. So therefore, CO2 molecules don't really want to stick together. You know that though, because CO2 is what phase in the air that you breathe in and out. It's a gas. And so CO2 molecules don't stick together. So, but in order to get them together, you gotta get them really cold. And that's why dry ice, cold solid ice, is really cold dry ice. I mean, not dry ice, CO2 ice. So this is really cold. And what it does is it doesn't like to stick together very much. It really doesn't. It just goes, you know what? Okay, we're gonna make a solid out of this, but then we're done. We're going directly back into the gas phase. And that's what sublimation is. It's when you go right from a solid to a gas with skipping the liquid phase. Ice doesn't do that. Well, water ice doesn't do that. It goes and melts and then eventually becomes vapor. But it does not go through the liquid phase for CO2. And that's because of its intermolecular forces being very weak. And as soon as it gets a chance, you give it a little bit of energy, just a little bit of energy, and these things will fly apart. They don't want to be near each other, okay? They're not polar. Okay, so that is what dry ice, that's sublimation. Water will do this too. The water can do this under certain conditions. Very, very cold temperatures, water can sublime. When my brother and I were kids one year, we were probably like 7 or 8, and growing up in upstate New York, Rochester, New York, it's one of the 3 snowiest cities in the nation. Yes, it is. Tons of snow. And what we wanted to try to do was say, hey, let's do this. Let's make some snowballs, and we did. And we took them downstairs. It was like January. And we took them downstairs, and we put them in this freezer. My parents used to have this freezer that, you lift it up open, and God knows what was in that thing. Probably body parts down at the bottom, but who knows? It's full of stuff that they never used. We took our snowballs and put them in the freezer, stuck them way down there so nobody would see them. And we came back in July, because we wanted snowballs in July. How cool is that? Get it? It's cool. It's cool because it's snowing. That's cool. Okay. So we would go and get our snowballs out. Sure enough, they had about half the size. Because even ice, liquid water, will sublime somewhat. And we can go back to that diagram. We could show you where the sublimation takes place. But there is a line on that diagram. The diagram for that water phase diagram did this. Okay. And here was your triple point. Well, right here is where sublimation takes place. That's where sublimation takes place down here. Right? So it can happen. So we do get some sublimation. All right, and with water. Okay, moving on. Deposition's the opposite. Deposition is the opposite of sublimation. So very simply, when you have a liquid going directly to a solid, which is what would happen with dry ice. So it's like condensation and boiling. It's like melting and freezing. These two go hand in hand. Sublimation, deposition, okay? Going from gas to solid. All right, moving on from that, we have some terms with solutions down here at the bottom I need to go through. And with solutions, you did this in Chem 1, you did. But when you have a solution, we'll be doing stuff with solutions, so let's go back to the terminology. You have have a solute, and you have a solvent. All right, solute, solvent, the most common solution on the planet. Anyone? Mary. Salt water. Correct, Mary. Ocean water. Salt water. Salt water. Salt solute. Water is a solvent. Sometimes water is called the universal solvent. It dissolves a lot of things, All right, so there's our two terms. Types of solution. I want to make sure I talk about types of solution because this is important. Because a lot of times we always think of salt water, right? We think of solid. So solid and a liquid. And those are, I would have to argue, probably the most important of the solutions you would study in chemistry. I mean, you are a solution, yes you are. I mean, we're made up of all kinds of water and stuff dissolved in and moving around our body. We'd be in big trouble, mister. Michelle, Full House. Okay, we all remember Michelle from Full House. Okay, 90s, good stuff. But these aren't the only kinds of solutions. You could have a liquid solution. Yes, you can. You can have a gas solution. Now, this is a good one with this. Solid and liquid is salt water, any kind of salt. And salt, NaCl is not the only kind of salt. There are hundreds of different salt combinations. Okay, lots and lots of salt. Salt just means metal and non-metal. Any metal combined with a non-metal, like copper sulfate, you put that in water, you have a salt solution. All right. So this is very common, but liquid. If you have ever, seen or consumed, but 21 means 21, so make sure you're 21. Something like vodka, you look at the proof number, it's usually 80 proof, which means 40% alcohol. 40% alcohol, 60% water. Yeah, 40% alcohol, 60% water. That's a mixture, it's a solution. You can't see anything in there except clear liquid, so it's a solution. Now, in that case, the alcohol is dissolved in the water because the alcohol is the lesser amount. So in a case like when it comes to liquid solutions, it's which one do you have the most of, and that is your solvent. Now, if you have something like, there are some rums out there that are 150 proof, that's 75% alcohol. In that case, the alcohol becomes a solvent and the water is a solute. Interesting, huh? But that's a different kind of solution. Gas. Hopefully you're breathing, right? You're breathing. That's a gas solution. You're breathing in air. Air is not just oxygen. Sometimes we say that synonymously. We just breathe in oxygen. Oh, no, you breathe in a lot more than oxygen. As a matter of fact, you breathe in more other stuff than oxygen. 71% of the atmosphere is nitrogen. 79. Is that right? 79, 21, and then there's like less than 1% of carbon dioxide, argon, water vapor on a humid day, more water vapor. These things are all gases, a mixture of gases, and you're breathing in the air to get the oxygen, but you're getting mostly nitrogen. So in that case, who's the solvent? The nitrogen, because it's the most. Yeah, 79%. 79%. So, all right, so there's an, and now what about solid? Can you have a solid mixture? Sure you can. Those are called alloys. An alloy is like solder or brass. Okay, you have heard of alloys before. You've learned about them in history class. You learned about the alloys. Okay, that was United States, Britain, and the Soviet Union during World War II. They were allies. They were allies, okay? Allies. But yeah, you have combinations of solids and solids. Solder is a combination of lead and I think it's tin, lead and tin, but you have brass, you have zinc and copper is brass, zinc and copper. And the one you have the higher percentage of is going to be the one that's a solute. It's that simple. So the one that's the most of is your solute. The one that you have the least of is your sol. I said that backwards. The one that you have the most of is your solvent. The one that you have the least of is your solute. All right, so remember that when you come to solutions which have the same phases. Okay, the one that you have the most of is your solvent. But we're also going to study these. That's the important solutions, and we'll be really focused on solutions, especially coming up in a couple of weeks of acids and bases, acid-base chemistry. Acids and bases are solutions, and we are going to do lots and lots with those. Oh, yes, we are. Okay, so those are some terms. There are terms that go along with solutions also. You might have heard these before. Saturated. Saturated, what does that mean? That means you can't get anything else dissolved in it anymore. It's got its maximum amount of solute dissolved in the solvent. It can't fit anymore. If you oversaturate, that means what you'll get is a precipitate will come out of solution. So I used to do this when I was a kid. When I was a kid, my mother used to buy Cheerios. She was, she's being healthy mom buys just plain Cheerios, plain boring Cheerios. So that's what we had in the morning. We pour those in. Mom would go out in the kitchen and she'd leave in the dining room. She'd have the little sugar bowl in the middle. Yeah, you know where this is going. You probably pulled this yourself, haven't you? Yeah, so I got my boring Cheerios. So what did I do? Get that sugar in there. Oh, it was so good and so good for you is sugar. No, actually not really. I'm just kidding. What they find, you eat your Cheerios and they would taste sweet, and at the bottom of the bowl, what did I eat? You get this mound of sugar, mound of this gray sugar. Why? Because you oversaturated. Milk has sugar in it anyways. Okay, that's called lactose. But if you add more sugar to it, that water in the milk can't hold it anymore. It comes out of solution as a precipitate. Precipitate. Okay, so that's another term that we need to know. I'm just looking here. How are we doing? We're almost done. You hang in there. Stop drooling and wake up. Thank you. Wipe that drool up. It's kind of gross. Not with your shirt. Never mind. All right. Saturation terms, miscible and salvation. Okay, miscible is just a fancy word for mixing. See that, miscible? It's miscible, that means they mix together. Water and salt. Salt is very miscible in water. It mixes quite well. However, oil and water are not miscible. They do not mix well. So there's that term there. You'll see that sometimes in this term here. We have salvation. Okay, salvation is what you get when you go to church. You get No, that's salvation. Never mind. You want to talk about church anyway. You shouldn't be talking about church. Kidding, for crying out loud, lighten up. What was that? Oh, salvation. Salvation is a term where something goes in to a solvent and gets surrounded by it. Let's go back to our salt water. So you have sodium chloride. A bunch of sodium chloride, some salt, you throw it in water, it dissolves, you know it does. You don't see it anymore, right? You taste it though, if you drink it, it tastes salty. So the salt breaks up into sodium and chlorine. And those sodium and chlorine ions are kind of floating around. This is universal for floating. If I do this anywhere in the world, okay, they know that I'm doing flotation. All right, okay, little charades for you, remember that. So salt, sodium and chlorine, and water will come along, polar water will surround. Now, this water being polar, the positive ends would surround the negative chlorines, and water would do the same thing with the sodium. The negative ends, however, would surround, and we get this water in here to surround. That's salvation. Salvation is dissolving, and when you put something in it dissolves, the solvent surrounds it and isolates the solutes so they can't get back together. Now specifically, if salvation is done by water, all right, that's called hydration, okay? That's called hydration. So I know you're dehydrated, right? This is hydration when I drink water. Well, not in the chemistry sense. In the chemistry sense, hydration is when you have specifically salvation occurring with the solvent of water. So, but alcohol dissolves things too. Alcohol is not a bad solvent. It can dissolve some things, alcohol will. And so it would not be hydration. If it's alcohol as a solvent, it would be salvation. That makes sense? So anytime anything dissolves and the solvent does this, salvation, hence solvent. However, if the solvent is specifically water, then it's hydration. So is hydration salvation? Yes, it is. Yes, it is. And last, like dissolves like. Maybe you've heard that before. And what that means is polar versus nonpolar. Water is polar. Water is polar. So water, being a polar molecule, there's our generic way of showing a polar molecule, will dissolve anything else that's polar. And many compounds, molecules are polar. So water is very good at dissolving many things, because many things are polar. But not everything's polar. And water does not do a good job with dissolving things which are not polar. Like oil and water don't mix, right? Well, because oil is nonpolar. So in order to dissolve nonpolar, you need a nonpolar solvent. And a nonpolar solvent is a good nonpolar solvent. Actually, soap works as a nonpolar solvent. You can dissolve oil. But you need like a carbon tetrachloride is a nonpolar. Carbon tetrachloride. Carbon tetra for chlorides. The ends are the same on the outside. That's a nonpolar compound, and that can dissolve other nonpolar compounds. So that's what it means by like dissolves like. Polar dissolves polar, nonpolar dissolves nonpolar, and they don't do very well at dissolving the unlike. So water can't dissolve oil. All right, I think that would wrap up for this week. We've done a lot of talking the talk. One problem we did this week. Next week we'll get into muy problemas grande. Oh, I love it, I love it, I love it. I love problem solving. I love it, it makes me whole.